Hello, Math 7 students. This is Utah Middle School Math Project 1.1a, using data to make predictions, or in other words, probability. To get started, I want you to try and define in your own words, without any other information other than your own background knowledge, what do you think experimental probability means? What do you think theoretical probability means? Students are going to talk in their groups and discuss and write down as we pause the recording. Ready, set, go. All right, what do you think? Let's start with probability first so that we can figure out experimental probability and theoretical probability. What do you think probability refers to? What does probability mean? You're in different seats, so I can't tell. Is that Joshua over there? Yes, Joshua. The chance that something will happen, yeah. I'm going to try and write that down. There we go. Okay, and understanding that probability is the chance that something will happen. What is experimental probability? How is that different than theoretical probability? Devin. Okay, try it and then mark down the results. How is that different than theoretical probability? What does theoretical probability mean? Liv. Okay. Okay, anything that you want to add to either of those things? Yes, Joshua. Okay. Okay, so suppose there are, did you say wasps? Blocks, okay. Okay, I was like, what? I don't want to grab any wasps at all. Okay, suppose what Joshua said, repeating for the recording, suppose there's 100 blocks and 30 of them are red. The chances of grabbing a red one are 30%. That's based on the theory of it. That's based on some calculations. Have we actually done the experiment to figure out? No, that would be the theoretical probability, or based on our calculations. Based on what we know is actually happening, or based on calculations. Experimental is exactly what it sounds like. You experiment and you see what's going to happen. So today, we are going to be collecting data to really truly see the difference between experimental and theoretical probability. So you have each been given a bag with a total of 12 tiles. So how many tiles are in your bag? 12 tiles. Some of them are green and the rest of them are blue. You will experiment, or you will do the experiment below, where you draw out 6, you draw out 12, you draw out 18, you draw out 24, you draw out 30. So you repeat it multiple times. What you're going to do is you're just going to shake the bag around. Without looking, you're going to reach in and pull out one tile. So go ahead and do that now. Shake your bag. Okay? Without looking, reach in and pull out a tile. Pull it all the way out of the bag so you can see it. Okay, and mark the results. Just do a G for green, do a B for blue, and you will list it here on draw number 1. We all drew number 1, so if I pulled out a green, I would list G for green. If you pulled out a blue, you would list B for blue. And put it back in the bag. Shake it up. Because otherwise, if you put it back in the bag and then you reach in and take one out, chances are you might be grabbing that same one, right? So we got to shake it all up. And do it again. Maybe switch partners, have someone else in the partnership grab, pull it all the way out, and write down what you got. Okay, voice is off. Stop shaking the bags. Let me have your attention. Thank you. Altogether, we have now done that as a class 2 draws. You need to repeat that to fill in 3, 4, 5, and 6. Then we'll pause and we'll discuss. So finish the experiment, 3, 4, 5, and 6 draws, and I'm going to pause recording as students do that. Okay. The next question that it asks, still related to this same experiment, based on that experiment, how many of the 6 draws were green? Look at my screen. How many of my 6 draws were green? 6. Did anyone else have all green? Okay, so you guys had some blue in yours? Good, that's even better. That's even better. For my particular experience, I had 6 green. So based on these 6 draws, how many of the 12 marbles or tiles, I use tiles, how many of the 12 tiles in the bag do you think are going to be green? You help me out. I drew 6 times. How many tiles do you think are going to be green? Understanding that there's actually 12 total. Talk with your groups. There should be more hands. Talk with your groups. What do you think? Okay, and now back to voices off. What do you think? Thank you for these hands. Dylan? 9 or 10. So you're saying even though they were all green, you think that there's still probably some blue ones, just not very many. Okay? Yes, Joshua? Okay, hold on just one second. We'll get there in just one second. Me personally, based on this, I'm like, yeah, they're probably all green. It's probably a lie. There's probably not any blue. Because in 6 times did I draw even one single one? No. I personally, I would guess that there's probably 12. Okay, maybe you feel differently. Now let's go on to somebody else. Joshua, you said you had how many green? 4 green, which means 2 of your draws were blue. Okay. So let's kind of make sense of this. Why did I think that all 12 of them were green in my own experiment? Why did I think that? Use something with the numbers here to walk through that. Luke?
Because if you get 6 straight greens and then you double the amount of draws,
Mm-hmm.
it would be logical because, like we did yesterday, how we balanced it out
Okay.
inequalities.
Yeah.
Oh, like doubling this side, but we have to double the other side.
Yeah. Great connection to equations.
We double the amount of draws. So if we want to truly balance it out, like if this was an equation, we'd do the same thing to the other side. So we double the amount of greens.
Okay, great. So right now I only experimented with 6 tiles, right? But how many tiles are there in the bag? 12. So what if I doubled the number of tries? I would probably double the number of times that I got green. So really truly, knowing that there's 12 total, I'm going to say a 6 times 2 is equal to 12. That's where I'm getting that information. Based on that, using Joshua's data, there's a total of 12 tiles, but we only experimented with 6 of them, right? So what if I decide, okay, let's double the number of tries so that we have 12 tiles. How many greens do you think we would pull out? How many greens do you think there are based on that? Joshua?
7.
You say 7.
Based on the multiplication, 8.
Yeah, based on the multiplication, I think it's a good guess to say 8. 7 maybe because you're saying it's just probability, it's just an experiment, we're not always going to be exact, and that's fine. But 4 times 2 is 8. So then how many blue tiles would there be? 2 times 2 is 4 blue. Okay, those are some good guesses. All you need to do is list how many green. You don't need to worry about figuring out how many blue, but seeing if there's 8 green and 4 blue, that would add up to the 12 tiles. Okay, that is the experiment. For part B, you're going to restart. You're starting all over with draw number 1. You'll do draw 1, 2, 3, 4, 5, 6, all the way through 12. So even though you've already drawn 6 times, that was a different experiment. Now you're drawing 12 times just for this experiment. Then you'll pause and you'll say, based on that, how many green tiles did we see? And then use that to make a prediction. How many do you think there are? After that, what does it look like you're going to do next? 18. After 18, what do you think is going to happen next? Yep, so each time you're restarting. Okay, you are restarting every single time. What questions do you have? This experiment is very likely going to take us most of the day. If you get done, there are some questions that follow that we can answer, but my main goal is let's just see if we can get through this experiment, do all of our draws, and collect all of our data. Yeah? Okay, we're going to pause the recording as students do this in class. I will also complete my own experiment and put the data up here for the screen so that we have something to go off of. Pausing the recording now. All right, I repeated my next experiment with 12 tries. I got one single blue, so based on that, I am going to now predict that there are 11 greens because out of 12 different tries, so that represents 12 tiles, I got 11 green, so I'm now going to guess that there's 11 in the bag. Now I'm going to repeat this 18 times. Pause the recording again if you want to try and do this on your own, but I will pause the recording so I can do this 18 draws. All right, for this next experiment, I drew 18 times. You can see the results. Out of 18 draws, 14 of them were green. So based on that, I'm going to have to do some interesting work here to figure out how many out of 12. I could just isolate it to the first 12. I could say out of 18, so 14 out of 18 were green, and 14 out of 18 simplifies to 7 out of 9. That doesn't really work very nicely with the 12, so I'm going to have to start making some guesses as to how many I think there are. 7/9 is about 3/4, so maybe 3/4 of this bag, or in other words, 9 out of 12 could be green. That's a guess. I could say this is a little bit more than 3/4, so maybe I could say 9 to 10, anywhere between 9 and 10 out of 12 would be green. This one is a little bit harder to calculate, and I don't want to get into all the sticky calculations. Just do your best. Based on that, how many greens do you think? I'm going to pause the recording one more time as I draw out some green and blue tiles here 24 times and record the data. All right, here is 24 times drawing green and blue tiles, and of those 24 times, I drew a green tile 23 times. Based on that information, 23 out of 24 of those draws, that doesn't simplify to anything. If I try and simplify it to 12ths, I end up with, let's see, 11.5 out of 12. So maybe I can say, obviously I can't say that they're all 12 of them green because I do know that there's at least a blue one, but maybe I'm down back to saying that there's 11. 11, 9 to 10, 11. Obviously there's not very many blue because I keep on drawing out the green. Let's repeat this again for 30 times. I have already done this experiment as well, so let's take a look and see. There's the 30 times. When I drew it 30 times, 25 of them were green. This one works a little bit nicer as I'm trying to make a prediction. 25 out of 30 of them were green. That 25/30 simplifies to 5/6. And here's what's nice about 5/6 is, I'm going to do it up here. 5/6 can easily turn into 10/12. They're equivalent ratios. The 6 is doubled to be 12, so the 5 is also doubled to be 10. So if there's 12 tiles in the bag, I'm going to guess that there's probably 10 of them green. So back to 10 again, went from 11. Well, I went from all 12 of them were probably green to guessing 11, down to 9 to 10, back to 11, and now I'm back to 10 again. We're going to end the video here with just this experiment, saving the discussion for our next video. So that's it for today. Thanks for watching, and we'll see you next time.